Hi there. I'd like to introduce you to the favourite tool that I've discovered during lockdown. So my favourite new thing, which is great. I was originally looking for something with which I could do card sorts with the students. So each individual student could do the card sort, and I could see how the whole class were doing. And Desmos was the thing that I found, but it does oh so much more. So let's have a look at it. So this is what it looks like to begin with. But we will, of course, sign up or log in. So here we are, logged in now. I have to say, the one thing I very slightly struggle with is finding where all the stuff that I've created is. So I look under these bits and pieces, and there's some wonderful things there, like there's a scientific calculator. But that's not what I'm looking for. I'm looking for my classroom activities. So if I go all the way down, and I click on my classroom activities, you can see ones that I've created in the past, or in fact you can't yet, because you have to click on custom as well for your activities. So here we go. Here are the ones that I've created in the past, and that's where I'm going to create my new one. So it's going to be called classroom activity, not a polygraph. I'm going to click on new activity, and it's about the IV characteristics. Which I think that's how we spell it, which is the current and the voltage characteristics for various different things. So looking at graphs for resistors, bulbs, etc. Okay, so that's what it's called. But this program, this software was written for maths teachers and people doing maths. So it works. Is got kind of built in loads of functionality around equations and graphs and tables and all of these things, which makes it perfect for me when I'm trying to teach about experimental data. So it says it's in a small screen. I think this screen will work okay, but yeah, it's just the way that I'm working. I'm only working on kind of like a quarter of the screen at the moment. So I'll say, yeah, that's fine. Now, looking down the side, we can see a bunch of kind of different questions types. So there's the card sort at the bottom, which is the one that helped me really discover this. But I think we're going to start with a check box. So I might be tempted to call it multiple choice, but multiple choice means, in this case, it means there's only one right choice. Checkbox means there can be multiple answers. So here we go. So we'll put a title on to our slide called measuring resistance for a resistor. I'm actually going to put an instruction on as well. So the instruction in this case, also the notes, is going to be a question. The student is told to measure the resistance of a resistor. What should they measure? And we'll give them a few different options. There we go. And that's all right. I don't think I need a graph or an image. I could add those there. Anytime this green button turns up, you can type in an equation. I could add more information. I could add a picture or something if I wanted to. Well, let's do that. Let's add a picture in there, shall we? Just in case you don't know what a resistor looks like. So I'll drag in a picture of a resistor. And then we're done. But let's just do a quick preview to see that it looks okay. Measuring resistance of resistor. You'll notice I've numbered the question. That's quite handy for when you're going through the questions later with the students. I wanted the question really to be above the answers, so let me move that around. So I drag the kind of, I think it's called a hamburger, isn't it? So I drag the hamburger, and yeah, that looks perfect. Okay, let's go on. Let's do question 2. Now, what type is question 2? Question 2 is going to be a very simple question. So I'm going to give it the same title, actually. So that for all of my first 4 questions, they're going to be similar. So I've pre-typed them. I'm just copying and pasting them in to save you some time. But here I want to put a function and or equation. So I think the equation that I'm going to put in is resistance is voltage, and I type / divided by current. So they are going to use a variable power supply, and where do I want them to type it? I give them a text input box, and well, let's move it down. Okay, let's move that one up then. Let's have a look. Student realizes to work out the resistance, they need to measure current and potential difference. What is wrong with their setup? Oh, I wanted them to have a picture, didn't I? So what we'll do is we'll add in some media to that, and here's the picture that I've drawn. So let's have a look. There we go. That is the question and the space for them to type their answer in. Okay, so it's going really well so far. Let's add a third question, and this third question is going to be, I think, slightly harder. It's going to be a complete the table and sketch the graph question. So I'm going to need a table for them to fill in. So here's the table coming, and I'm going to need them to sketch the graph. Now for this, if I want to show them a graph, I would click graph, but if I want them to draw a graph, I drag over sketch, and I can customize the background. Let's do that. Okay, so I click on the triangle. It wasn't very intuitive in the small screen, but let's have a look, go down. There we go. I want an editable graph. And that's what I want. If I click on the, well, actually let's move things around a little bit first of all. Actually what I'll do is I'll fill in the table with the information. So to fill in the table, it's really easy. I just type in whatever I need, wherever I need it, and it will create as many rows as I need, basically. I will now type in the rest of this whilst you're paused to save you some time. So there we go, I've typed in the rest of my table, so that's ready to go. But I want to make sure I select exactly what they're going to do on the graph. So I'm going to tell it a few different things. So by clicking on this spanner, it lets me set the different axes. So we're going to have potential difference on the x-axis, I think. And we're going to have the current on the y-axis. I need to be consistent with my letters. So potential difference. What I'm going to do is I'm going to go from -20 to 20 on both. Now I'm doing that deliberately. They don't actually need -20 for the potential difference, but they might make a mistake. So this enables them to make a mistake. So let's have a look at this now. So complete the table and sketch the graph. There's the table. You see I've left a couple of blank spaces for them to fill in their answers on. And here's the graph that they can draw on, and I'll show you how what that'll look like, exactly like for the students in a minute. And let's do a final fourth question. So for this question, I'm going to say, put some instructions again. I'm going to give it the same title that we've had before. But this time I do want them to introduce a graph, so I'm giving them a fixed graph. And on that fixed graph, at this point, I can change the scales to be more sensible. So I'll change the scales from, well, leave the scales as -10 to 10 for potential difference. And for current, we'll go from -20 to 20. But this is the clever bit. Here, I just type in the equation I want. So I'm saying y is equal to 3x. So I'm saying the current is equal to 3 times the potential difference. Okay, so whatever the value of potential difference, the current is more. Now I could change that to be, to be any number that I want there, and you see it changes the steepness of the graph. I could add multiple graphs if I wanted there, including ones with more complicated functions as well. But for now, I'm just going to go for y equals 3x. And I need somewhere for them to type their info, so I'll give them a little table, and that little table is going to be I'm going to tell them the potential difference, and I want them to work out the resistance in ohms. So for 2.0, 4.0 and 6.0. Okay, and as I say, there are loads of other types of question I could put here. So kind of like just true, false, yes, no, multiple choice, bits and pieces, well worth having a look at. So I've created 4 questions. The 5th and final question I'm going to add just says the end. And I've just figured that's a useful instruction to tell them when to stop. Actually, I probably would go on and have a look at more questions about bulbs or diodes or the other sort of things that I need to measure the resistance of. But I think that's right. I could change it later. I might tweak it later. But for now, I'm going to press publish. So pressing publish puts it out there to everyone. But for now, before I'm going to actually run it with students, I need to create a class code. So if I create a class code, I've now got this 6-letter class code. That's unique to me, that's unique to this quiz. In fact, it's unique to this instance of this quiz. I could have multiple ones that I use with different classes. So let's go and have a look. So let's show the student link. If I put that up on my screen, copy and paste it into a PowerPoint or something like that, then those are the instructions that the kids need to do to get onto my quiz. So let's do that now. So let's have a look at them going along. They go onto my quiz, so students.desmos.com, TJNTNW. Let's join it. Give ourselves a different name from me. Call ourselves Alan. Here we go. And this is the questions they get. So they can change how quickly, how slowly they do it. But if you now, as the teacher, look at the dashboard, you can see who has logged on. So I could see all of my different students logged on and looking at this. So, and I can see where they are, which question they're on. I can see whether they've got some right or wrong, perhaps. But I can look at their individual results. So let's go back and let's have a look at what the student's doing. So they think the answer for that is current and voltage. This is the old trick. He's trying to trick me. So the voltmeter and the ammeter are the wrong way around. Submit it and then click next. This is the graph one. Now, if they're actually plotting it, they may plot it as kind of little dots like this. If they're quick, that's roughly what it looks like. Or they can actually, because this is a straight line, they can spot that it's a straight line and they can plot it using a straight line graph. So you can use it in a number of ways. If they make mistakes, they can erase it. They can add information to the table here, so 9.0, 15.0. They click next, they go to this, they go, ooh, that's a hard one. I need to use my calculator for this. There is actually a calculator built in to Desmos, but I need to enable it for the question, and I forgot to do that. So I should have enabled it. They'd be able to type it in, and the answer, I think, is 0.33 for all of the questions here. So you can see the sort of questions I've been using it for, the sort of questions you can type in. I think it's fantastic. I think it's really brilliant. And then back on the teacher view, look, you can see where my students have got to, who's reached the end. If I want to, I can click on a question and I can see all of the graphs that all of the students have drawn, or all of the tables they've typed in, or all of the answers that they've written. So I can get a whole view of my class on a range of different questions. Easy to do, and it's free, and it's just brilliant. And then I actually tend to use the student view, which I then share with the students as I work through and tell them what the answers they should have typed and selected actually were. So that's Desmos. Probably so much more that you can play with. I'm doing it a bit of a disservice by just doing that. One thing I will show you, so if I go back to that question, if you want to share this one, so you can share the activity, get a code basically. If I do that, if I give that to other teachers, they can just take my quiz and reuse it. Or you can add it to collections and things if you've got a range of different ones you want to use. Absolutely brilliant. Brilliant for doing kind of mathsy questions, but brilliant for doing experiment-based questions as well. So have fun with Desmos. Thank you very much.